So what they're giving you here is the after image. They want the pre-image coordinates, where k, the scale factor, is 3. So we don't even need to draw a picture here.
Okay.
What's the A? In other words, this is really A prime, B prime, C prime, and D prime. So tell me what A is.
6 or 9?
Everything's been dilated by a factor of 3. We're going backwards.
So 0?
Not 0. We're not subtracting. We're multiplying everything by 1/3. In other words, if we had a rectangle that had been dilated to a big rectangle like that, you with me?
Yeah.
And this is the one they're giving us. So what do I have to do to the smaller one, the original image? If the dilation is by a factor of 3. What's the smaller image going to be?
1/3 of the...
Exactly. Okay. So what's 1/3 of A prime?
1 and then 0.5, or...
Leave it as a ratio. You're dividing each one by 3. You see how I got that? 1 comma 2/3?
Yeah.
Okay. Give me B.
So 1/3 of -1?
No. -1 divided by 3, and those are two completely different things. In other words, you're taking that number and you're dividing it by 3. That's minus 1/3. Now do that to all the numbers you see left. So what's the y coordinate on B?
2/3. 2/3.
And C?
1.
You're taking every number you see and you're dividing it by 3.
Yeah, for 3.
For C. We're doing C.
Oh.
Taking every number you see.
-1/3. -1/3.
And D.
1 and -1/3.
Yeah. Notice that is all we're doing here is going backwards. Had they given you this as the set of coordinates for the A, B, C, D, and they would have said the dilation factor is a factor of 3, tell us what it is, well, it's going to expand by 3. But they gave us the dilation and the after image. So they want the pre-image. So instead of multiplying everything by 3, we got to divide everything by 3. All right. All of these are the pre-image. That was a quadrilateral, this a triangle. It doesn't really matter. Does not matter how many sides the figure has. The process is the same. If you're going from little to big, you multiply by the dilation factor. If you're going from big back to little, in this case, you divide by the dilation factor. So what is it? This is really, I wish they'd have done this because it makes more sense. So tell me what M is. Taking 8 divided by 1/4. What's that? Don't use a calculator. If you don't know how to do this, we need to talk about it.
I just forgot how to do it.
Okay. When you divide by a fraction, you flip the denominator and multiply. One of the most fundamental rules of algebra. When you are dividing by a fraction, you flip the bottom and multiply. So what is 8 divided by 1/4?
Wait, so I flip 4 over a 1 and
multiply.
divide.
Instead, no, you can't do that and divide, you change the problem. But if you do that and multiply, it's the same thing.
Multiply by 8?
Yeah.
Or 8 to...
No, this is the same thing as this. Remember, division is the same exact thing as multiplication by the reciprocal of the denominator.
32.
Okay, so that's 32. Let's keep going. What's the 6 become?
24.
Okay. And N.
Negative 4 times 4 is negative 16.
Okay. Keep going.
16.
And O.
24.
Negative 28.
Yeah.
Now, again, we're merely going backwards. In other words, the problems you originally got when talking about dilations was they would give you those 3 points, M, N, and O. And then they would say, what's the dilated figure with a K of 1/4? And you would multiply each of these by 1/4 to get these. So that's why I like labeling these M prime, N prime, and O prime. It's because these are the dilated ones. To get back to the original ones, we got to reverse it. So instead of multiplying by 1/4, we divide everything by 1/4.
Okay.
Okay, what's 2/3 divided by 3/4 equal to?
Hold on, so you do 2/3 and then flip 4 over 3 and then 8. So 2 in the 4th.
Tell me how to write this. What is this the same thing as?
2/3 times 4 over 3.
Okay, now do that math.
Yeah, 8 over 9.
There's your answer for that problem. Okay, that's how you divide by a fraction. And it doesn't matter whether that is a fraction or not. If you are dividing by a fraction, you flip and multiply. You got to do 2 things. You got to flip, and you got to, instead of divide, you got to multiply.
Yes.
Okay? All right. Now, let's look at 3 is really no different than 2. Tell me, and again, I don't know why they didn't do this. To me, it seems like a no-brainer that that's x prime, that's y prime, and that's z prime. In other words, after the dilation, this is the triangle you get. So before the dilation, what are the points of the triangle?
-6, 2, y, -9 or -6, 6, 2, -6.
Okay, that's all there is to going backwards. Is instead of multiplying by the dilation factor, you divide by the dilation factor, depending on whether you're going forward or backward. Okay, when they tell you the pre-image, you know they're giving you the after image, right?
Yeah.
They want to know the pre-image. So you know you're going backwards on every single one of these problems. You're not going forwards. Forwards would be where they gave you the pre-image and they wanted to know the after image.
Yeah.
All right. What else you got for me? Probably going to need to send it to me. Geometry is awfully hard to verbalize, as you can see why.
I'm sending it to you.
Okay. How's things going? How's your football career going? You stayed injury free?
What?
Have you stayed injury free?
Yeah.
Well, that's good. That's usually the problem that everybody tells me is they injured something and they're out. So you're still playing?
No, it's over.
Oh, the season's over?
Yeah.
Oh, I didn't realize it ended so soon. Wow, that is pretty quick.
Yeah, it started pretty early though.
Oh, did it start before school started or?
Yeah.
Oh, I didn't know that. Okay. So you're done with football. When do you like have a spring?
Football starts in January.
Oh, really? So you're not done with it for very long. Okay.
For one, you just set 5y minus 7 equal to 3y plus 21.
Yeah, because Cpctc, corresponding parts of congruent triangles are congruent. And this AD is the corresponding part to AB. So they're equal. So 5y minus 7 equals 3y plus 21. Solve that real quick, step by step.
Add 7 to the right side on 21, it's 28, and then subtract 3 from 5, that's 2y, so 2y equals 28. That is like 14.
Okay. Number 2.
The 5x.
Basically for that angle.
Isn't 5x minus 10 equals 35?
No, they're not vertical angles. Notice that this angle right there is equal to 5x. Let's call that. We don't want to call it x. Let's call it y. Okay?
Yeah.
So y is equal to what?
X or 35?
Based on vertical angles.
Oh, 5x minus 10.
Okay. That's what that angle is. Now, what is true about y and this angle? Y equals what?
35?
No, it's the complementary angle. Whenever you're looking at a right triangle, the two acute angles are complementary. Means they always add to 90.
All right, so 55.
Uh-huh. So I don't even need that. I can just go back and I know y is 55. So now solve that equation.
So 55 equals 5x plus 10.
Mm-hmm.
You would
5x minus 10.
you would subtract
5x
or
minus
you
10.
would add you would add 10 to 55. So 65 equals 5x and x equals um
I don't mind you using your calculator on these.
all right,
Go ahead.
13.
Okay. The only thing I really don't like you having to use your calculator on is when you're multiplying single digits by single digits. In other
All
words,
right.
if I tell you 8 times 9 and you got to look that up on your calculator, that's a problem. You want to know all of your single digits by memory.
Okay.
Trust me, it makes math a whole lot easier if you do that. I don't care if you don't know what 8 times 17 is. That you can do on a calculator. But if you have to do these on a calculator, you will be slowed down. It would be like somebody slowed your 40 speed. What's your speed in the 40? Do they even time that?
Yeah, like a 4-7.
Well, it would be like somebody giving you a 5.0 in the 40. That's how bad it would be. If you do not know how to do single digit by single digit positive and negative numbers,
All right.
addition, subtraction, multiplication, and division, all four of those things for single digits you need to be able to do. Okay? Dividing 65 by 5? No. You can use a calculator for that. All right, let me hold on a second. Scroll down a little bit. Now notice that the instructions say Cpctc worksheet. What's the Cpctc stand for?
Congruent.
No, actually not.
What is it?
It's corresponding. Corresponding parts of congruent triangles are congruent. In other words, in this case here, now let's look over on the left. It actually, we're using it more on the one on the left. That's the corresponding part of the triangle on the left. That's the same corresponding part of the triangle on the right. Corresponding parts of congruent triangles, that triangle is congruent to that triangle, are congruent or equal. So you end up with 5y minus 7 equals 3y plus 21. So that's what the Cpctc means. Corresponding parts of congruent triangles are congruent. And all of these have to do with that. In other words, every problem we're looking at congruent triangles. WXY. This one is congruent to this one. So, based on that, I'm now going to erase everything so we can see all the numbers. Tell me what is true. Trying to solve for P. So we see, first of all, we look at our picture. We see a P there and we see a P there. Well, what can I say based on that? Based on corresponding parts of congruent triangles are congruent?
That would set those equal to each other.
Give me an equation. Don't tell me that. Give me an equation, because I don't know what you mean exactly.
7 pi p plus 3 equals 2p.
Plus 13? No. Does that look like it equals that?
I don't know. No.
Well, can you see? That's pretty long. That's pretty short. Always apply a ballpark test. Never just write something. Look at it and see if it makes sense. So no, that can't be true. Here, let me draw the congruent triangles again. There's the first triangle. Here's the second triangle. What are the corresponding parts? Based on the letters, give me a letter. The blue triangle, what's the corresponding part of the blue triangle that's equal to the corresponding part of the red triangle?
B.
Not B, the longest side, XZ. What is the corresponding part to XZ? XZ is congruent to what?
YW.
Good. Now, give me an equation. What is XZ equal to?
B. Or 2p plus.
Hold on, you're talking YW. Tell me what XZ is equal to.
Isn't it the same thing though?
Well, we're going to make that equal, but we need to know what XZ is. Read it. They're numbers. There's a number, there's a number.
4 and 18.
Okay, that's what I wanted, 22. Okay, and what's that equal to?
9p plus, or 9p plus 13.
Okay. 7p plus 13 plus 2p, which is 9p plus 13. Now solve that equation, you'll have your answer.
22 minus 13.
That's 9.
9 equals 9p. Xp equals 1.
There you go. In other words, when you have two congruent triangles like this, you have to find their corresponding sides and make them equal to one another. Well, the longest side of both triangles is that one right there. So those are what are equal to one another. And then you just have to come up with an equation. The secret to math is always translating what you see in a figure to an equation and then solving that equation. All right, how about number 4? Number 4 says this triangle is congruent to that triangle. Now notice that they have not given you any corresponding, well, yes they have. Give me one equation I can write.
Negative 8x plus 9y.
Hold on. Go
39.
from left to right. It's not negative 8x. There's no reason to add line segment AC to line segment DG. That makes no sense.
Negative 5x
corresponding to that, that's the corresponding side that equals that corresponding side. Corresponding parts of congruent triangles are congruent. So first of all, you have to figure out what are their corresponding sides. What's the corresponding side to AC?
OD.
Okay, so make those equal.
5x plus y equals 19.
Okay. Now, notice we can't solve that. That's two variables and one equation. We cannot solve for either x or y. But now give me another equation. And now I'm going to be able to solve for it.
Here's 3x plus minus 8y equals 20.
Ah. Now I have two equations and two variables. I always know I can solve for that. And that's what we have to do, is it's back to algebra. You do not escape algebra when you take geometry. Algebra is it's at least 50% of geometry. Okay? So you got to be able to solve these simultaneous equations. How do I solve these two? I got two variables, two equations.
Elimination.
Elimination or substitution?
Substitution.
Actually, when they are in standard format is when you have the x and the y on the left side and you have a number on the right side. That's standard format.
So
whenever you have two equations that are both in standard format, elimination is always easier. So let's use elimination. If we we could use substitution, but we would have to do a lot of math before we would even get to the problem. So we don't need to do that with elimination. What do I need to do here? If that's equation 1 and that's equation 2, which is kind of the way you should think about this, how do I eliminate a variable? That's what elimination means. Once you decide that you're going to solve it by elimination, you have to eliminate a variable. How do I eliminate a variable, and which variable?
I have no idea.
Well, if we multiply equation 1 by 8, it becomes what? Multiply both sides by 8. You're always allowed to do that with equations. You're always allowed to do anything you want to the left side as long as you do it to the right side.
40.
Okay, minus 40.
Wouldn't it be positive 40 because it's a minus 5 and
No,
it would
we're
be
multiplying by plus 8. Multiplying
minus
that
40.
side by 8, and we're multiplying this side by 8.
Minus 40. Hold on. Minus 40 and then 19.
I'll multiply that by that.
152.
Hold on. Multiply 8 by the y.
8y.
Okay, that's key. That means that we're going to be able to add these two equations and y is going to get eliminated. That's the whole important reason why we're multiplying equation 1 by 8, is so that I can eliminate the y variable. And use your calculator to do this.
152.
Okay. Now, that's no longer of interest to us. The only thing we have is these two equations. Now, one of the rules with equations is you can always add or subtract two equations. So add these two equations. What do you get? Add those two. It's negative 3 added to negative 40. Did I lose audio? You still there, Bradley?
Yeah, it was muted. Negative 43.
Okay. X.
Equals.
Now what happens when you add those two?
It gets rid of y.
Ah, it's eliminated. That's the whole reason we call it elimination. So we're trying to eliminate one of the variables. Now, you still got to add those two.
Yeah, equals 172.
Okay. Now solve for x.
Four.
Negative 4.
Yeah.
Okay, so x equals negative 4. Now, what's y equal to? If x is equal to negative 4.
We just put negative 4 in for
Okay, go ahead and do it.
so
Remember, minus 5x plus y equals 19. That's our simplest equation to work with. And we've solved for x. So now let's solve for y.
So put negative 4 in for y.
No, for x.
For x, and then that would be 20.
Okay. So what's y?
Hold on. So 20.
So you have 20 plus y equals 19. What's y?
Yeah. So then you do 20 plus y equals 19. And then you subtract 19 from 20.
No, you're trying to isolate y.
So I don't. You just do it.
Huh?
Oh no.
You were one hair away from the answer. Don't give up. You had 20 plus y equals 19. Solve that equation for y.
Wouldn't I just subtract 19 from 20?
Oh, hold on. Here's the way you solve equations. If I'm trying to solve for y, then I have to get rid of everything that is associated with y. Well, I currently have a 20 that's being added to y. So it's not the 19 that I'm worried about. It's this, the 20. So I got to get rid of the 20. How do I get rid of the 20?
Put it on the right side.
How do you do that?
Erase it, and then
You
put it over
subtract
there.
it. You subtract it. You subtract 20 from both sides. So y is equal to 19 minus 20. What is that?
Negative 1.
Okay, so now we have both of our answers. Now, because there's a lot of math in here and we could have made a mistake, if you're taking a test, you might want to at least check to see whether these solutions make sense. So because we did all of our math, that equals that, let's make sure that that is now equal to that. So is this true? And if it is, then we probably have the right two answers. See what I'm saying?
Yep.
Don't really want to use these two because we got our answers by using those two. So let's make sure that the bottom two works. So is that true? How am I going to figure it out? We got our two solutions. What do I do with them?
Put them in.
Okay, so I got minus 3 times minus 4 minus 8 times minus 1. And that's always the way to do it. Do not do any of this in your head. Substitute the numbers and then simplify. Well, what's minus 3 times minus 4?
What? Minus 3 times minus 4? 12.
Okay. And that's a minus 8. So what's that equal to?
8.
12 minus a minus 8. What is that equal to?
4.
Nope. 12 minus a minus 8. The two negative
20,
signs turn into
20,
a plus sign.
20, 20, 20.
Huh. That's the same thing it was supposed to equal to. That means we got the right answer. In other words, when you're checking it, you have to make sure that it's correct, because it's easy to make mistakes. So you got to go back and check your answer. All right, now in this case, they say that triangle 1 is congruent to triangle 2, but you kind of have to make sure you get the right. When you have two triangles that are congruent to one another, it means their angles are equal, all three of them. Angle A is equal to angle C. What is 30 degrees equal to?
Oh, 7x.
No, that's not the angle that's not the congruent angle.
B.
Notice, yeah, I gotta reflect this over dB to get these things on top of one another. Okay, so it's not that angle that's equal to that angle. It's this angle up there. And you have to notice that. You have to realize that. Otherwise, you're not going to get the answer right. Okay? So, and notice that if these lines were parallel, that would be true. 8x plus 2y would be equal to 30.
Okay.
So I'm going to say 8x plus 2y equals 30, and I'm going to write it in standard format because I can see what the problem here is going to be. I'm going to end up with two equations and two unknowns. And whenever you end up with two equations and two unknowns, you got to put it in standard format and solve by elimination. What's the other equation that's true?
7x plus 2y equals 24.
Now, how do I solve that? That's equation 1, that's equation 2. This is all about how you solve a system of two equations and two unknowns.
Substitution? Or elimination.
Elimination, I'm telling you, elimination always works better when both equations are in standard format. If one of the equations was y equal 5x plus 1, that's different. That is not in standard format. That's fully defined for y, and then I would use substitution. I would just go look for y's, and wherever I found a y, I would substitute 5x plus 1. But we don't have that here. We have both equations are in standard format. So how do I eliminate a variable?
Multiply the first equation by -2.
Why -2?
Because there's already a +2. So you have to do negative.
Turn it into a -2. What do you have to multiply it by to turn it into a -2?
1.
-1. So I'm going to multiply that by -1. I got to multiply the right side by -1 also. So what is my new equation 1?
Negative 8x minus 2y equals -30.
Okay. Now cross out that one because we've got a new one here we want to use. Now how can I eliminate a variable?
You just cross out.
Hold on.
2y and -2y.
You add the two equations, and it's important for you to understand that's what you're doing. You can't cross out the 2y with the -2y. What you're doing is you're adding these two equations like that.
Yeah, but it cancels them out anyway, so you could just...
It does, but it only does it if you add them. You actually can also subtract equations. And notice if we go back to our original two equations, we really didn't need this step, multiplying by -1. We could have just subtracted the two equations. Let's do that, just to show you that it can be done. And sometimes it's the easier method by a lot. Take equation 1, subtract equation 2. What do you get?
Um, 1x equals 6.
Notice how much easier that was to subtract the two equations. We solved it in one step. Now let's go back and do it the hard way. And this is a little bit of a delicate thing because most people don't handle negative numbers very well. So that's why I didn't object when you said multiply the first equation by -1, because that's fine. I don't have any problem with that. Let's multiply it by -1. And now we're going to add the two equations. So what's our new equation?
-8x minus 2y equals -30.
Okay, now you got to add equation 2 to the new equation 1. What do you get?
-1x equals -6.
And now you got to do another step. So what's x equal to?
It's 6. The answer.
So we got the same answer, but we had to go through 2 extra steps. In other words, we not only had to multiply the original equation 1 by -1, but then after we added them, we had a negative x equals a -6. We had to divide both sides by -1. So there were absolutely 2 extra steps involved by doing it this way. And the only advantage is it allowed you to add the two equations instead of subtracting them. But you don't have to do that. You know how to do subtraction. And sometimes if you notice two equations, for example, I had this as my first equation, and I had this as my second equation. Well, I can see right off the get-go that I can eliminate y by subtracting the two equations. I don't have to add them. I can subtract them also. If I subtract 2y from 2y, I get 0. And this gives me the answer in one step. So don't forget about being able to subtract equations. Sometimes it's a lot more efficient than doing what you have to do to add equations. All right, now let's look at number 6. Tell me what corresponding sides are. What's the corresponding side to EF?
FG.
Okay.
Or GF.
That's true. Okay, so what can I say?
1 minus 3a equals b.
Okay. And what's another corresponding side? What's the corresponding side to that?
15 equals 3b plus 3a.
15 equals 3b plus 3a. Correct. Now, notice, I still have the problem. All problems come down to 2 equations and 2 unknowns in these problems here. The thing is that now I have to solve that system of equations. And that is not in standard format. So I could do two things. I can put it in standard format, or I could use substitution. And I have found that if one of the equations is fully solved, and this one is fully solved for B, substitution works better. So take that for B and substitute it into equation number 2. What do you get?
What? Oh, 15 equals, I don't know, what?
You're substituting whatever B is equal to. What is B equal to?
1 minus 3a equals b.
Aha. Now I still have a 3a over here. And notice that I've taken my system of equations and I've reduced it to one equation and one variable. That's always what you're trying to do. Nobody can solve two equations and one variable, or rather one equation and two variables. But once I get one equation and one variable, I can always solve it. Now help me solve it here.
All right, so 15 equals 3 minus 9a plus 3a.
Okay, keep going.
And then
gather all your variables. Gather all your variables on one side. Gather all your numbers on the other.
So add negative 9a plus 3a, which is negative 6a.
Okay. Put your numbers on the other side.
And then 15 and 3 on the other side.
Tell me the number.
3.
Don't tell me 15 and 3. That doesn't tell me anything.
18.
No.
12.
Yes. In other words, you have to subtract 3 from both sides to get rid of this 3. You don't add 3, you subtract 3. Remember, you always do the opposite of whatever it's doing. Right now, that 3 is being added to the right side, therefore you got to subtract. And now what's A become?
6. Or 6.
Solve that for A.
6. Or 2.
No and no.
Negative 2.
Okay. Biggest problem I find with students is dropping negative signs. For some reason you think 2 is the same as negative 2. It ain't even close. You might as well say infinity. Negative 2 is not the same as 2. You got to get the right sign. Otherwise you get no credit. If you put A equals 2 down here, you would get no credit on the problem. Okay? Now, what's B equal to?
You just plug negative 2 into B.
Not into B. We solved for A.
Into A.
Okay. So what do you get? Which equation do you use?
The first one.
Good.
So 1 minus, hold on, so 3 times negative 2.
Don't do that math, just do it. In other words, write it like that. You can always simplify it, but when you try
1 plus 6 equals B.
Correct. But what I'm trying to tell you is that if you attempt to do this in one step instead of 2 steps, you're much more likely to get it wrong. Do this as your first step. And I tell that to everybody. You could bring me Einstein and I would tell him, do this. Just substitute for A. Then reduce it. And you get 7 equals B. Now you have an A and a B. Okay? And you usually use the easiest equation. I actually could have solved for B by using that equation, but notice how much harder it is.
Yeah.
In other words, it's just a more complicated equation. It's got bigger numbers and it doesn't have B fully defined. I'm trying to solve for B. So I'm always substituting into that first equation when I'm trying to solve for B. I only have one step. I substitute whatever we came up with for A, and then I simplify. Let me have a look at this. This may be more than a 3-minute problem. How's things going in geometry? What kind of grade are you getting, Bradley?
Like 75.
Okay. And you've got your final, and on your last day of school is like the 21st?
I think, I don't know.
Okay. So if we had a session every Sunday, we'll have 2 more sessions before your final. Is that correct?
Yeah, 1 or 2.
Okay. Well, your final undoubtedly makes up a large portion of your grade. So your final is going to be big. I know that only because I know I'm always jam-packed the 3 weeks before Christmas break. And I'm going to be jam-packed the next 3 weeks also. Now, I have you down for every Sunday. In other words, next Sunday and the following Sunday. So that's good because it wouldn't be easy to come up with a new time, at least not during the week. So if Sundays work for you, I would suggest sticking with your Sunday appointment, and we'll have 2 more appointments. And is this review material right here what you're covering now, or is this part of your semester review stuff?
Semester review.
Okay. So we can just keep going on this stuff here. You sent me page 1 of 1. I'll need another page, but that's probably what we want to do over the next 2 sessions that we have, is go over your semester review material so that you'll be ready for that test.
All right.
Okay? All right, Bradley. I'll talk to you next Sunday at noon.